Good morning, everybody. Welcome back. I hope everybody had a great weekend, had a chance to get outside, get some sun, get some exercise, whatever. You know, I know we're getting to this last stretch of the school year here, but I'm glad that you guys are tuning into the video, still keeping up with your assignments. It is very important. We're covering very important stuff, and there will be one more test to kind of finish up the class. The test will be a small test, not as big as the one that we took before, um, but it will be definitely bigger than a quiz. It's something that if you don't complete, it's going to hurt your grade. So you need to make sure you just keep logging in, um, and we'll go from there. Okay, so if at this point you need to be trying to catch up on work, any missing assignments, um, if you don't have the test done, you absolutely need to get both parts of it done, like today, immediately, because it's going in the grade book as a 0 otherwise. Now, if you turn it, if you turn it in late, I will still accept it, but the school year is coming to an end. You need to be focusing on the stuff we're doing now. So, anyways, let's talk about today's assignment. So this week we're going to be working with inequalities. Inequalities are when we work with these little symbols here, and you can kind of think of them as, the hungry alligator. Remember, the hungry alligator always wants to eat the bigger number. So just like, we always put it towards the open mouth, towards the bigger number. So think of it as a little alligator or whatever. Okay? So that's what we're going to keep in mind for this assignment. Now, the last couple of weeks, we've been working on solving for, um, solving for a missing variable. And we found that, there's only one answer when we're solving these questions. Inequalities are different, though, because an inequality suggests that there's more than one answer for these type of questions. Because let's look at this here. This is saying, which of the following is a solution to the inequality below? Well, k is less than negative 5. There's a lot of numbers less than negative 5. In fact, there's infinite numbers less than 5. All right, if you did a little number line here, maybe 0 would be right here. Your positive numbers are this way. Negative 5 might be right here. Maybe negative 3 is right here. Negative 1. Negative 8. Negative 2. So it doesn't need to be a masterpiece of a sketch. It doesn't even need to be drawn neatly. Not when you're doing your work, at least. So you just do a little sketch if it helps you think about the question. And until you can do these, until you kind of get the hang of it, it's probably not a bad idea to do a little sketch like this. So what we're trying to do is we're trying to find all the numbers that are less than negative 5 from these choices here. Now, I actually wrote down every choice on this number line. Let's go through each one. Negative 2, or let's see, negative 5 is right here. Negative 2 is over here. But we want numbers that are less than negative 5. So negative 2 won't work. Same with negative 3. That's bigger than negative 5. That won't work either. Right, these are bigger to the right, smaller to the left. Negative 1 is also bigger than negative 5. That won't work. So the only choice here is negative 8, because negative 8 is less than negative 5. And we were looking for numbers that we could plug in for that. So that doesn't mean it's the only answer, though. So there's a lot of numbers less than negative 5, right? So k less than negative 5, well, the answers for that, well, like I said, there's infinite. Maybe negative a million. I'm not going to write that out, but let's do negative 100, negative 8, negative 5.1, and so on. Right? There's many different numbers you can put in here. These are just some examples. But what if this was written slightly different? What if we had something like this? K is less than or equal to negative 5. This means, this sign here means that it can be this. Let me do darker color. So it can be either this or it can be equal. Let's do it down here. So it can be this or equal to negative 5. So this means that these same numbers would work that I have above. These would all work for k. It could be other numbers too. I could throw in a negative 6. Doesn't really matter. Any number less than negative 5. But also negative 5 works for the second one because of this bar. And that's something we'll see with some other examples. But for this question here, it wasn't like this. We're not worried about that one right just yet. But we'll keep it in mind. This was the correct answer. K equal to negative 8. All right, so is f equal to 9 a solution to the inequality below? So this is perfect. This goes just with what I was talking about. 9 is, if it's greater than or equal to f, and we're saying that f is 9, then we're going to test this out. 9, 9 versus 9. Now, 9's not bigger than 9, but it is equal, so we know that this will work. So let me do kind of a new question here. What if we had the same? What if we had? We want to see, is this a solution? Does 8 equal x work for this below? So this is kind of a new question. Would this work? Pause the video and think about it. Welcome back. So again, you would test this out to see is this a solution? So you'd plug that in down here. X is, oops, sorry, let me do 8 greater than 8. Is that true? You should have said, no, that's not true. So A would not be a solution because we don't have that bar there. If we had the bar, this would work, but we don't. But in this case, this question here, we did have the bar, so it is a solution. All right, let me skip ahead. All right, let's take a look at this one. Which of the following is a solution to the inequality below? So there's a couple different ways we could solve this. I'm only going to talk about one way today because next week or later throughout the week, we're going to talk more about the best way to solve these. So in this case, we're trying to see which of the following below works for this. So what we can do is try out each choice. So we're going to try out 9, 12, 8, and 6. And we're going to see if plus 6, plus 6, plus 6. Then we're trying to see if this is greater than or less than or equal to 13. Well, we know that 9 plus 6, we know this is equal to 15. 15 is not less than 13, so this won't work. We know that this, 12 plus 6, is equal to 18. This also won't work. 8 plus 6 is equal to 14. 14's still not less than 13. But 6 plus 6 is equal to 12. And 12 is less than 13. So that works. So it has to be 6. Alright, let's take a look here. We're going to have to divide these out. This one's a little, the numbers are a little messy, but we can do this. We're going to do it the same way. I'm not going to necessarily write out each one now, just because you should have an idea. Well, let's see. If we plug in 3, 7, 1, and 5, well, maybe I will. I think it's going to get confusing if I don't. So I'm going to do the same thing again. So it'll be 52, 52. Sorry, you got to watch me write it. So less than or equal to, and we're going to do 105 over h, 105 over h. I'm going to leave that blank actually. 105, 105, and then we're going to do plug in 3, 7, 1, and 5. Now I'm going to start off down here at the bottom because these are a little easier. I know 105 divided by 5. Well, I know 2 times 5 is 10. So 20 times 5 must be 100. That means that there's one extra 5. So it must be 21 5s go into 105. So this right side here is equal to 21, which we know 52 is not less than or equal to 21. So this won't work. But what about this next one? 105 over 1. Now 1 over 5 over 1 is 105. And 105 is greater than 52. So this will work. Now we can try 105 divided by 7. But we don't really need to. Right? We did 105 divided by 5 already, and that was 21. If we divide by a bigger number than this, it's going to be a smaller number. So this actually, we don't even have to do it. It won't work. Well, 105 over 3, we might have to try that one out. So let's go over here to the side. 105 divided by 3. So 3 does not go into 1. Does not go into 1 here. So we need to look and see, does it go into 10? 3 goes into 10 3 times. 3 times 3 is 9. Go ahead and subtract. 10 minus 9 is 1. 3 doesn't go into 1, so you bring down the 5. Does 3 go into 15? Yes, it does, 5 times. 5 times 3 is 15. There's no remainder, so you're done. So 3 goes into 105 35 times. So this here is equal to 35. And 35 is not greater than 52. So this won't work. This means that this third choice here is the only one that works. And notice we had to check them all because this says select all that apply. So that means there can be more than one answer. And whenever you see these check marks, I believe it's those type of questions. Select all that apply. Very, very important. You'll see questions like this on, M-Step and, I don't think on the SAT, but maybe you will see stuff like this in the future. So just be careful. So our only choice here that works was H equal to 1. All right, let's do one more. Looking for a harder one now. Okay, let's just do this one. So this is another select all that apply. That means we're going to have to try out each choice again. So 4 plus 6. I'll write that in a second. So we're going to try these out for each one. Okay, so there we go. So we have 4 plus 6. And what we're going to do is we're going to try out each choice here. We're going to try out when D is equal to 1. So let's do that. We're going to try that out. We're going to do this for each equation here. Okay, so 4 plus 6. And then we'll try it when D is equal to 3. 4 plus 6, and then when D is equal to 9. Say, there we go. Okay, so let's try out each choice. We have times 3. We're going to try out times 9. We're going to try it times 11. Now, we might not need to actually try out every choice here. So remember, when you're doing questions like this, it's okay to, if something makes sense to you and it saves you some work, that's okay. Okay, those little tricks help, and you'll see what I mean in a second. 6 times 1 is 6. 4 plus 6 is 10. 10 is less than 64. So this first one works. Let's try out this next one. I'll use blue. So we have 18. 6 times 3 is 18. Plus 4, 22. That works too. What about here, though? Now we're multiplying by quite a bit bigger number. I have a feeling that could change things. But let's see. 6 times 9 is 54. Plus 4, 58. Now, we could try out this next one, but I know if we did 4 plus 6 times 10, well, 6 times 10 would be 60 plus 4, so 64. So we know that times 10 would work, but anything bigger will not. So you actually don't need to plug in this last one. If you want to, you can, but we're just going to use logic to cancel that out. Save some time. So this means that all these first 3 choices work, but not this one. So it's these three that are your answer, because this is a select all that apply problem. And that's how you solve these. As you get higher up, you might see some negatives like here, but it doesn't change anything. Just go ahead, plug in the numbers, see if it works or not. See if the result is true or false. If it's true, it's a solution. If it's false, it's not a solution. And remember, with inequalities, you're going to have infinite solutions for most of these, for these type of questions at least. There's not just one answer, there's a ton of answers. And we're testing out one of them in these cases. So that's all I have for you guys. Thank you for listening. Have a great rest of your day, and I'll talk to you again soon this week.